So now we're going to take a look at surface area of a cone. A cone is similar to a pyramid, okay? So a cone is similar to a pyramid, except that the base is made up of a circle. So what we're going to be looking at is a pyramid, except that the base is made up of a circle. So that kind of changes things a little bit, but we're still going to use somewhat of a very similar aspect to solve for the surface area of a cone. The cone also has two parts to the area. The first part of the cone is the base area. Okay, so the two parts, we have the base area, and then we also have the lateral area. In the case of a pyramid, the lateral area is made up of a bunch of different triangles. Sometimes they're the same size, sometimes not. In the case of a cone, it's going to be one triangle. Let's take a look here at a cone. So this is a cone. We have an oval for the base, and then we draw a pyramid in here, or it's not a pyramid, sorry, a triangle, and that kind of gives us a look of a cone. If we take the net of it, it looks like this right here. So I've drawn this out ahead of time already, and you can tell my drawing isn't great due to the fact that it's on a computer here instead of by paper and pencil. Might be worse on on paper. But what you'll notice here is that this is the lateral area, this kind of what looks something like a triangle, and then we have this circle base at the bottom. So this would represent a cone. And to find the area of a cone, we need the radius of the circle, and we also need the slant height of this top piece here. The slant height of the top piece is going to be the same throughout the entire lateral area, and we usually label it right along the side here. If we're given the height, it's straight down. If we're given the slant height, it's along the side. So it's a little bit easier even to see than a pyramid. Now, to find the area of the circle is something that we should recognize and know how to do. Pi r squared. So it's just find the area of that circle. This lateral area is a little bit different. Now, the lateral area resembles a triangle, and we're actually going to use the idea of a triangle to represent our lateral area. And we're going to use that as our template. We have the height of the triangle, that's our slant height, but this length right here is our base. And our base is the same length as the circumference of our circle. And so we can write out our that length there as circumference is equal to 2 pi r. Okay, so this length is 2 pi r. Now, when we write out our formula to find the surface area of a cone, remember, if we go back to, if we can quickly get back in there, surface area is equal to the base area. So we said this was pi r squared, that's the area of our circle, plus the area of that triangle. And so base times height divided by 2. So it's going to be 2 pi r times the height divided by 2. That's how we're going to write out 2 pi r8 divided by 2. Now something you might, and that h is actually the slant height. So we're going to change that to slant height, 2 pi rs divided by 2. Now what you might notice is we have 2 over 2. And if we see that, we can cancel that out. And we're actually just going to have pi rs. And that's going to be to find the area of our, the area of our surface area of our cone. Now we can also think of that, let's just go out a little bit here. Surface area is equal to the base area plus the lateral area. Okay, and so we remember, this is the base area, this is the lateral area. Depending on what we need to find, we're going to be finding either both pieces, one piece, or the other piece. So let's go through and let's find the area or the surface area of this cone right here. Now you'll notice that we have our radius, and I already have that prepared there. So I'm going to write radius in there, or r is going to be this distance right here, and our slant height is along the side. Now the slant height is the side of our cone, not the up and down. So it's always going to be listed on the side. We're going to use our surface area formula. Now again, for a cone, we can always use this formula, pi r squared plus pi rs. So we can always use that same formula for the surface area of a cone. Pi doesn't change. Our radius in this case is 6 inches. And then we have pi, and our radius again, 6 inches, and our slant height of 10 inches. All right, when we do the calculations, now again, we can do the calculations just in straight order. So I'm going to do pi times 6 squared plus pi times 6 times 10. Now you'll notice I'm just going to show you in the little screen. You might be able to see, you might not be able to see. Oh, that's going to be a little tough. Okay, I just wrote it out completely straight through with my calculator. Okay, I don't hit equals at all until the end. And when I do hit equals, I'm going to get that the surface area is equal to 301.59 inches squared. And that is how we find the surface area of a cone. Use the formula, plug in the radius and the slant height to solve for the surface area. Now let's take a look at a contextual question. So number 2 is a contextual question. It talks about an ice cream cone that has a diameter of 7 centimeters and a slant height of 12 centimeters. Let's determine the area of the cone that's going to be covered in chocolate if dipped. Well, I'm just going to do a quick little drawing of an ice cream cone. Now it's not going to be a great drawing due to the fact that, well, I'm doing it on the computer, so it's a little bit tough. But here's the top of our ice cream cone, and then we're going to draw it like this. So it's kind of like a upside down cone. There you go. It's not great, but that'll work. We have an upside down cone. Now, the one thing that we know about our cone is that we are given the diameter of our cone, and we're told that the diameter is 7 centimeters. And we're told that the slant height along the side here is 12 centimeters. Well, to find the surface area of this cone, we can use our formula. SA is equal to pi r squared plus pi rs. There's our formula. Now we know that this is our base area, this is our lateral area. Let's think now in the context of an ice cream cone. We're going to dip this ice cream cone. An ice cream cone does not have a top. Okay, it does not have a base area. It only has sides. So it only has the lateral area, which means that we're actually not going to include the base area. We're going to actually leave that out. So we're only going to find this area right here. That's it. Pi rs. That's the lateral area. That's all we're going to find. Well, we need to know the radius. If our diameter is 7 centimeters, then we can find our radius by dividing by 2. And that's going to be 3.5 centimeters. So our radius is equal to 3.5 centimeters. Okay, that's just dividing by 2. You can do that. Some will take a little bit more work. You might need a calculator depending on the number. Other ones you can probably do using mental math. All right, once we have that, let's plug in our values here. So surface area equals pi times the radius, 3.5 centimeters, times the slant height, 12 centimeters. And we get that the surface area that is going to be coated is pi times 3.5 times 12, 131.95 centimeters squared. 131.95 centimeters squared. So this is now our answer, right? So we've come up with our solution to this, but because we're dealing with a contextual problem, the answer needs to have some context to it as well. So we can say that the area of the cone that will be covered is 131.95 centimeters squared in size. So on there, there we go. Okay, in size. There we go. That is a nice solution to this contextual problem. Make sure all of your contextual problems that you do, so if there is context to it, you come up with some sort of contextual answer. If you're just told to find the surface area of a cone, just a basic value is needed.